So yesterday we talked about parent functions. Parent functions are the functions that start everything. Your parents are the parent function of your family, because without them you don't exist. If we don't have parent functions like these, we do not have a starting point to do transformations. That's what you need to know. Along with that, parent functions all have unique names and shapes that go with them. If I'm looking at y equals x, that is a linear function. It creates a line. You don't have to put the word straight in front of it. That's redundant because every line is straight. If it wasn't straight, it'd be a curve. I feel like I have to say that a lot, even to adults that I'm talking to this about, because I go, you don't have to call it a straight line, right? Because someone goes, I need you in a line. But when y'all were younger, when y'all were getting lined up out in the hallway to go to the restroom, go to recess and stuff, the teacher had to say a straight line because y'all didn't know the concept of line and non-line, linear and non-linear. But now at this point, if I say linear, that's a line, and lines have to be straight. That's precision. Any questions? Quadratic, U-shape. We also call that a parabolic function, but you won't hear the word parabola until you're in Algebra 1 and Foundations, which is next semester, okay? So you'll hear me start saying quadratic, parabolic functions a whole lot more, transitioning into January, going towards May. But for right now, just know quadratic, U-shape. That's a squared. Quadratic is also one of your vocabulary words that's going to be on your quiz tomorrow. So make sure that you know what's up. Half U-shape, square root, we read it as y equals x squared. It makes an R shape with the actual y-axis, but it's a half U-shape when it's by itself. This has an endpoint right here. It never goes past the origin. So if you need to know that, mark that. That is an essential piece of information. Any questions there? Absolute value is a V shape. We read it as y equals the absolute value of x. So V in value, V in shape. Everybody good? From there, we started talking about vocabulary in different sections. The first two was x-intercept and y-intercept. The x-intercept is when the graph crosses what? The x-axis. Written with y is equal to what? No, y is equal to what? 0. X has to exist, but y has to be 0 for an x-intercept to occur. Does that make sense, Zai? Thank you. A y-intercept is when the graph crosses what axis? The y-axis, where x has to be what? 0, but y has to be a number. Does that make sense? Everybody with me? So we were able to identify our x and y intercepts on our actual graph. We knew that A and B were x-intercepts because it crossed the x-axis. That is the horizontal axis on our coordinate grid. We knew that C was our y-intercept because it crossed which axis? The y-axis. The x-axis goes left and right. The y-axis goes up and down. Okay? For it to be negative on the x, left. For it to be positive, right. For it to be negative on the y, it has to go down. For it to be positive, it has to go up. Any questions? Coordinate pairs was also a discussion vocabulary term that we used 2 days ago on bell work. That's what this is. A coordinate pair is an ordered pair. Probably don't look at me. I love y'all to death, but the work is right there. If you're staring at me during the discussion, how are you relating it to what's happening on the paper? Because I don't see the... Do you see the math behind me? I'm trying to figure it out myself. I love that y'all make eye contact, but I need your eyes to contact that board, okay? Look up there. Sorry, people who are watching this review on the recording, my bad. But they keep staring at me, and it kind of scares me a little bit because the board's in front of it. So we were able to work 4 examples, finding just the intercepts. I color-coded mine to match what I had at the top. We saw that there was how many x-intercepts here? 3. X-intercepts. 2. So we had to write 2. Does that make sense? We saw how many y-intercepts? 1. So we had to write 1. How many x-intercepts did we see here? 1. So we wrote 1. How many y-intercepts? 1. So we wrote 1. Everybody with me? Looking at 3, how many x-intercepts? 1. So I had to write 1. How many y-intercepts? 1. So I had to write. 1. There we go. 4, how many intercepts? 2. So I had to write. 2. How many y-intercepts? 1. How many did I write? 1. Any questions? Those who weren't here, the video is already posted for this. This is a review. If you have any questions, make sure you ask them. Sir, quickly, go. Next vocabulary was that of a vertex, maximum, minimum. The minimum and the maximum will always be the vertex if it's an absolute value or a quadratic function, meaning if it's a V shape or a U shape. Any questions? I was going to do U in sign language, but y'all don't know that that's U. So, V or U shape, absolute value or quadratic. They will always have a vertex. Linear functions do not have a vertex. Cubic functions don't have a vertex. Square root functions don't have a vertex. Exponential functions do not have a vertex. Notice, two of those you have not heard yet. You will hear exponential and cubic later on down the road. They usually come in when we talk about sequences, okay? That's also in unit 6, 7, 8. That goes towards next semester, not right now, okay? So, if I'm looking at this, highest or lowest point is the vertex. When we look at the highest point, that's our maximum. If we see the lowest point, that's our minimum. That's where the extra vocabulary comes in to help. Everybody with me? Everybody still here? So, when we have a maximum, we write it as y equals a number. When we have a minimum, it's y equals a number. That's because it creates a horizontal line. If you don't know that, I would write that in. Meaning it's going to make a zero slope at the line where it's going to be the lowest or the highest. I would probably write this down. If the math teacher's writing it down who has the degree, I think the non-diploma having students should write it down. The non-diploma having students who are not in Algebra 1 yet, who are trying to work their way to Algebra 1, who will be taking a state test next year, working their way towards Algebra 1, who can still use these notes next year, working their way to Algebra 1 students. But that's just me. I didn't know that you get to decide. Okay. Just me, though. So, looking at this graph, we identified that we had a valley and not a peak. A peak meaning a mountaintop, the highest point, and a valley meaning the lowest point. So, we had a valley here. I'm going to write my arrows for this graph so I know that it's pointing upward. Always do that if the graph doesn't do it for you. Find where your arrows are heading and always put them there. That's precision. Because when you start graphing these on your own, you have to have precision because it is a standard that you have to meet outside of the regular math curriculum standards. So, the lowest point, that's the vertex. I color-coded it to match that. It was at 0, -4. Make sure you know your scale factor. This is going down by 2s, not by 1s. We call the lowest point the minimum, and it's located at the line y equals -4, horizontal line. Any questions? We wrote this piece of information right here because I said it at the top, but I wanted it to be next to the examples. Absolute value and quadratic functions only have a vertex. Linear functions, no. Cubic functions, no. Square root, no. Exponentials, no. Only two are the ones that have a definitive middle point that cuts them in half. So, we found which one here? Is this a max or a min?
Max.
A max. What about this one?
Min.
This one?
Min.
This one?
Max.
Thank you. So from there, we see that there's my maximum line, my minimum line, my minimum line, and my maximum line. Meaning my arrows are pointing downward from the max and upward from the minimum. Any questions there? Make sure that you have this piece as well because that helps you. The max or min is always the y of the vertex. It will always be the y because there's a 3. There's a 3. -4, there's a -4. -3, -3, 2, and 2. From finding the highest and the lowest points, you see what's going on now? You had your epiphany? There you go. Your moment of truth, your moment of wisdom. I love it. So, I just love seeing the looks on the faces when you finally go, oh my goodness, that's exactly what she just said. Looking at this, we talked about the highest and the lowest points that affect the y. We then have to talk about symmetry. Y'all will talk about a more in-depth symmetry, meaning even and odd functions, by the end of this unit. But at the beginning, we're just talking about symmetry in general, meaning where does it cut the graph in half? So, where does it cut the graph in half? At a vertex. So, my vertex was right here in the middle at 0, -4. So, that's the x value that it cut it in half. It was at x equals 0. That's what these bottom 3 questions talk about. Any questions here? From there, we did some examples because it was pretty straightforward. It says, find where the vertex is, draw your line, find the point where x occurs. So, if we're looking here, it's just like the upper example, meaning my vertex was at 0, 3 at the top. So, x has to equal 0 because the y-axis is the line x equals 0. All of these had symmetry. They just didn't all have symmetry to the y-axis. What you're going to learn is these two ones right here, 1 and 4, and I'm going to write this up here, 1 and 4 are even. The reason why they are even is because they are being split in half by the y-axis itself. To be an even function, you have to be cut in half by the y-axis where you're able to fold over and meet your other side precisely and exactly. 2 and 3 are what we call line symmetry. They're just random symmetry of lines. These are precise because they have symmetry to the y-axis. So, the information we should add here is that the symmetry will always be the x value of the vertex. Make sure you write this in. Make sure you write this in. Everybody got this? If you don't, you're good. Any questions on the quick review of what we did yesterday? Now, we're on our last characteristic that is pretty important for us in identifying functions and their pieces, is the direction of the graphs. Direction is a big thing because it tells you if you have a max or a minimum. It tells you where your domain and range are going. It helps you in those aspects. So, looking at the next section, anyone still writing this? Everybody good? Okay. It's either going to open upward, meaning we are seeing that shape going this way with arrows pointing up, or it's opening down where we see the shape where arrows are pointing down. That tells you end behavior. Also notice I made what kind of shape? A U shape. So what kind of function is that? Can you tell me the name? Quadratic. Thank you. So a quadratic is the best example of this because it has both arrows pointing in the same direction, just like the absolute value function, which is the V shape. So imagine the graph as a cup. Would this graph be the cup on the left or the cup on the right? The left. Because just because you can't see the arrows doesn't mean we can't put them, and they're both facing which direction? Upward. In other words, does it open up or open down? Up. There we go. Because you're looking at the arrow's behavior. Any questions there? Everybody still good? Everybody still with me? It says determine whether or not each of the following functions opens up or opens down. So, what about number 1? Agreed. Any questions there? What about number 2? What about number 3? What about number 4? So the bonus question I'm going to ask here is, does number 1 have a maximum or a minimum? A max. 2? 3? 4? Thank you. Do you see how the arrows correspond to where it's going? Any questions? Any at all? What I need you to do for me is do numbers 1 and 2. I'm going to put a timer for about 10 minutes. Shouldn't take you too long. Thank you. Those should have been the correct ones. Any questions?
Yes.
You need to ask them.
I ain't got no question. I see what I messed up.
Any questions? Grab out that packet I just gave you. Name and date on there. That's 3.3. Is it a function? Should not take us long at all.